So, hello students, today in this lecture we are going to do some numericals related to our previously done topics like del, gradient, divergence, curl, okay, and the various theorems related like Gauss Divergence theorem, Stokes theorem, Green's theorem and Helmholtz theorem. So, in this lecture we are going to practice some of the numericals. I have written here 5 numericals. The first numerical is for any scalar function v is equals to xyz, as it has no I, j, k unit vector, so it is a scalar function and it is mentioned in the numerical question also. Find the gradient. So we know that on this side I am going to do their solutions for the first question. And for what is for the gradient, the gradient of this can be done by like gradient is simply del v. Okay, as v is the scalar function, so gradient is del v. So this is equal to del is, that is I, or I am going to write down here I into curly by curly x plus j into curly by curly y plus k cap curly by curly z. This is my del function and v is simply x, y, z. Okay, so simply multiply this x, y, z with this del function and it will gives you the answer in the form of a vector quantity. So firstly, partial differentiation of x, y, z with respect to x. So this will gives you simply y, z, I cap, plus when differentiating this with respect to y, so this will gives you x, z, j cap, plus when differentiating with respect to z, so this will gives you x, y, k cap. Okay, so this is your final answer for the gradient. Okay, this is the solution for the first question. And for the second question, and question is, if b vector is equals to 2xy square I cap plus 2y cube j cap plus xyz k cap, find the divergence. So what is divergence? Divergence is dot product. Okay, so for the second question, we have to find out del dot b vector. Okay, this is we have to find out. So just write down the same, like what is del? This is curly by curly x I cap plus curly by curly y j cap plus curly by curly z k cap. This is your del function. Take its dot product with the given vector, that is b vector, dot with b vector is 2xy square I cap plus 2y cube j cap plus xyz k cap. Now simply do their dot product, that is multiply this with this and curly by curly z with xyz. And the result for the divergence is a scalar quantity. It does not have I, j, k terms in its final answer. So the result is a scalar quantity. So just it will gives you partial differentiation of 2xy square with respect to x. So this will gives you 2y square. Okay, this will gives you 2y square. Then next, plus partial differentiation of 2y cube with respect to y. So this will gives you 6y square plus now the third term with respect to z, so this will give you xy. Okay, just simplify it. So this will give you 2y square plus 6y square. So it is 8y square plus xy. So this is your final answer for the second question. Okay, now just see the third question, that is, if a vector is equals to 8x I cap plus y j cap plus 5z k cap, find the curl. Okay, so you have to find the curl for this third question. So what is curl? So curl is, that is the cross product. The cross product with the del, that is the curl, and we are going to solve the curl with the help of determinant. Going to solve the curl with the help of determinant. Like for the third question, this is my A vector and I have to find out its curl now. So curl is del cross A vector. And how it is written in the form of determinant like this: I cap, J cap, K cap. What is del? That is curly by curly X, curly by curly Y, and curly by curly Z. Okay, and now write down the A vector. This is 8x here. Here it is only y, and here it is 5z. Okay, now just solve by doing their cross products as you solve the simple determinant. So it is solved like, so I cap this, multiply this with this minus this. Okay, that is the curly by curly y of 5z minus curly by curly z of y. Okay, so this is for your I cap. Then minus j cap, multiply this with this curly by curly x of 5z minus this with this, that is curly by curly z of 8x. This is the term for j cap, and similarly for k cap plus k cap, multiply this with this curly by curly x of y minus this with this, that is curly by curly y of 8x. Okay, now as you have seen here that this is the z term and we have to take its partial derivative with respect to y. Okay, so this will gives you the 0 answer. Similarly, here it is also 0, here it is 0, here it is 0, again 0, and here it is again 0. Okay, so this will gives you the final answer of 0 I cap plus 0 j cap plus 0 k cap. That is, the answer will come out to be a null vector, and as if del cross A comes out to be 0, so then this will result in, hence del cross A is irrotational vector. Okay, hence del cross A is irrotational vector. Okay, so this is your third question. That means if del cross A comes out to be a null vector, so then we simply said that it is a irrotational vector. So this is your final result for the third question. Now let's start with the fourth question. Yes, in the fourth question, a vector is given, that is v vector is equals to x plus 3y I cap plus y minus 2x j cap and x plus az k cap is a solenoidal vector. The condition is given here that it is a solenoidal vector and you have to find out the value for this a. That what is a? And what is the condition for solenoidal vector? That if del dot this v vector is equal to 0, then it will become the solenoidal vector. Okay, so let's start with the fourth numerical now. So starting with the fourth numerical, fourth answer. So for solenoidal vector, what is the condition? For solenoidal vector, its divergence is 0. Okay, so this is the condition for the solenoidal vector, that divergence is 0. So for here, it is del dot v vector is equal to 0. This is the condition for solenoidal vector. And now just solve it. What is del? That is curly by curly x, as we have written in the previous three numericals. So I am going to write down here directly. So del dot v comes out to be curly by curly x of x plus 3y. And as we know that the del dot v gives you the scalar quantity, so there will not be I, j and k. Okay, so it can be simply written as curly by curly x, x plus 3y plus curly by curly y of next term y minus 2x plus curly by curly z of third term, that is x plus az, and this is equal to 0. And from here we have to find out the value of this a. This is our question. Okay, so just solve it. So partial derivative of this, so first term it comes out to be 1 plus, and when this is partial derivative with respect to x, so this gives you the 0. So 1 plus 0 plus, here it is again 1 minus, for this term it is 0 because here it is x and here it is y. Okay, and for this term plus 0 because here is x and here is z. Okay, and for this term plus a, and finally it is 0 as per our solenoidal vector condition. So just solving it, so this will gives you 1 plus 0 plus 1 minus 0, and this will give you 2 plus a is equal to 0. And finally the a comes out to be minus 2. So this is the final answer for the fourth question. Okay, so this is the final answer for fourth question. Now let's see the fifth question that is written here on the board. The fifth is, a vector is given that yz is equals to I cap, yz I cap plus xz j cap plus xy k cap. Show that it is an irrotational vector. Okay, so as we have also find out one condition for irrotational vector in this third question also. So condition for the irrotational vector is that its curl is 0. So we have to just solve its curl, that is just do the del cross A and it will comes out to be 0, and we have simply proved that it is an irrotational vector. So just let's start doing this numerical now. So for the fifth numerical now, yes, for fifth numerical, a vector is given, that is yzi plus xzj xyk, and we have to show that it is an irrotational vector. So simply do its curl. So del cross a vector. So this will, I'm just going to write it again in the form of determinant to solve its curl. So it is I cap, j cap, k cap. Here it is curly by curly x, curly by curly y, and curly by curly z. And just write down the terms for a vector, that is yz, xz, and xy. Okay, so this is my del, this is my a vector. Okay, now just solve it as you simply solve the determinant. So this will gives you I cap. Just do the cross multiplication, curly by curly y of xy minus curly by curly z of xz, okay, minus j cap curly by curly x of xy minus curly by curly this with this z of yz, like this, and finally plus k cap, multiply this with this, that is curly by curly x of xz minus curly by curly y of yz. Okay, this is how the determinant is solved, and doing the calculations now, so I cap when partial derivative with respect to y, so this will gives you x, and here it is again x minus x minus x, okay, plus sorry minus j cap, so here comes out to be y minus y plus k cap, and here it is z minus z. So this will gives you again a null vector, a zero vector. So this is 0 I cap plus 0 j cap plus 0 k cap. Therefore, irrotational vector. Hence proved. Okay, so this is what is required in the question number 5, that show that it is an irrotational vector. So del cross A comes out to be 0 here, and that's why it is an irrotational vector. Now let's do the next, these two numericals that are based upon the Gauss Divergence theorem. So in this sixth numerical, evaluate f ds. F is any vector, okay, and its surface integral is taken. You have to evaluate its surface integral of f vector, where f vector is given as x cube I cap plus y cube j cap plus z cube k cap, where S is the surface of sphere, and it is given by x square plus y square plus z square is equal to a square using Gauss Divergence theorem. So you have to apply in this numerical the Gauss Divergence theorem to calculate the surface integral for f vector. And let's do the solution now. Solution for the sixth numerical. Okay, yes. From Gauss Divergence theorem, so surface integral is converted into the volume integral, that we know. Okay, and f ds, that is the surface integral for f vector, it is equal to del dot f dv. Okay, this is as per the Gauss Divergence theorem. Now just put down this del and f vector to solve this surface integral of f vector. So this comes out to be volume integral of del is, that is curly by curly x I cap plus curly by curly y j cap plus curly by curly z k cap. This is del. Okay, take its dot product with f dot. So f vector is this much, that is x cube I cap plus y cube j cap plus z cube k cap. Okay, this is your f vector, and dv. and just solve this divergence first. So partial derivative of x cube with respect to x. So this will gives you volume integral of, that is 3x square. Okay, so as it is the simple solving of divergence, so it comes out to be a scalar quantity now. 3x square and plus 3y square plus 3z square. Okay, like this, 3x square plus 3y square plus 3z square dv. Okay, and just take 3 common, that is the volume integral of x square plus y square plus z square dv. So what is x square plus y square plus z square? It is given in the question that it is equal to a square. So it is the condition for the surface of the sphere that it is a square. So this will give you 3 in volume integral of a square dv, like this, and 3a square, just write it like this, 3a square and volume integral, and this is equals to the 3a square multiplied. So this one is the volume of sphere, because here the surface taken is that of the sphere. So this is the volume of sphere, and we know that what is the formula of volume of sphere, that is 4 by 3 pi a cube. Okay, so this will give you 3a square multiplied by 4 by 3 pi a cube. Okay, and finally solve it. So this will gives you just this 3 cancel out, and the final answer comes out to be 4 pi a 5. Okay, so this is your final answer for the surface integral of f vector. So surface integral of f vector comes out to be 4 pi a 5. So this is the solution for the 6th numerical. Yes, now for the 7th question. 7th question is determine again the surface integral of f vector, where f vector is 4xz I cap minus y square j cap plus yz k cap. Okay, and S is the surface of the cube. Now here it is the surface of cube instead of here as it is here in the sphere, and with coordinates x is equals to 0, x is equals to 1, y is equals to 0, y is equals to 1, z is equals to 0, and z is equals to 1 using Gauss Divergence theorem. Again, now let's do the solution. Yes, from the Gauss Divergence theorem, this is the condition that the surface integral is converted it into the volume integral with the divergence of that vector. Okay, so just simply put down the values of del and f vector as we have done in the last numerical. So this will give you a volume integral of del is curly by curly x I cap plus curly by curly y j cap plus curly by curly z k cap. Okay, this is del dot, take its dot with f vector. Now it is 4xz I cap minus y square j cap plus yz k cap and dv. Okay, now just solve this divergence first. So this is the volume integral of just the 4xz partial derivative with respect to s. So this will give you 4z, then minus this is 2y plus y. Okay, partial derivative with respect to z, so this will give you only y, and dv. Now just reduce it, so this will gives you 4z minus y dv. Okay, now as here the surface is in the form of the cube with these coordinates. Okay, x is equals to 0 and to 1, y 0 to 1, and z is again 0 to 1. Now just put down their limits and solve the integration first. So it can be now written as, now put limits of cube. So this will gives you, as it is a volume integral, so 0 to 1, 0 to 1, 0 to 1 for x, y and z. So here it is 4z minus y, and dv can be written as dx, dy and dz, like this. Okay, so firstly solve for x, then for y, and then for z. Okay, so this will gives you, now if I am going to solve firstly taking the integration with respect to x, so this will gives you, and taking the limit from 0 to 1 also. Okay, so this will gives, okay, so we are here, so just apply the three limits, that is x is equals to 0 to 1, y is equals to 0 to 1, and z is equals to 0 to 1. And this is the term after volume integral. So 4z minus y, the volume integral is converted into dx, dy, dz. Now, one by one, do the integrations and take the limits consecutively. Okay, so when you integrate this with respect to x, so this will give you 4zx minus xy, that take the limits from 0 to 1. And when you put down the limit 0 now, so this whole comes out to be 0. And when you put down the limit 1, so this will gives the same as 4z minus 5. So we got, after putting the limits of x, the same as 4z minus y dy dz. So after this, I am coming here. Now integrate this term with respect to y. So when you integrate it with respect to y, so this will gives you 4zy minus y square by 2. Okay, and take the limits from 0 to 1. Now dz is just left. dz is left. Now taking the limits from 0 to 1. Now firstly put down the limit for y is equals to 1. So this gives you 4z minus 1 by 2. Okay, and when you put down here 0, so this whole comes out to be 0. So we are left with 4z minus 1 by 2 and just one integration, that is dz. Now again do the integration with respect to z now. So this gives you 4z ka kya ho jayega? So this gives you 4z square by 2 minus, and here comes out to be z by 2. And taking the limits from 0 to 1 and just solving, so this will give you 2 minus 1 by 2. And when you put down here the limit 0, so this whole comes out to be 0. Okay, and just solve it and you got this answer as 3 by 2. So this will be your final answer for this surface integral of f vector. Okay, so by using the Gauss Divergence theorem, we can easily solve these type of questions. Like if the surface is some sphere, or the surface is some cylinder or a cube is there. So just put down their conditions that are given in the question and solve for the surface integral, or you can also solve for the volume integral or the. Okay, and similarly, the numericals based upon the Stokes theorems are there just for calculating the line integral from the surface integral line. Okay, so this is all about today's lecture, in which we have covered some of the numericals related to the very basic terms like gradient, divergence, curl, irrotational vector, solenoidal vector, and finally some numericals related to the Gauss divergence theorem. So thank you for this lecture. Thank you.